Let's discuss question number 52-53, which is a link data question from test sets. This is from heat transfer. Okay, steam in a condenser of a power plant is to be condensed at a temperature of 30 degrees Celsius with cooling water from a nearby lake which enters the tubes of the condenser. Generally, when it's not given, but then generally it is a counterflow exchanger. So steam is 30 degrees, it is just getting condensed, so temperature doesn't change, and water from nearby lakes enters 14 degrees Celsius and leaves at 22 degrees Celsius. So it's a counterflow heat exchanger. The surface area of the tube is given as 45 meters square. The overall heat transfer coefficient, which is U, is 2100 watt per meter square, and the specific heat of water is given as 4.184 kilojoules per kg degree Celsius. Okay, so temperatures are known, and so there are two methods in heat transfer just to calculate overall heat transfer Q. The methods are LMTD and NTU methods. So because the temperatures are known, so there are two methods, LMTD and NTU. The inlet outlet temperatures are known, so I'll just go with the LMTD method, where it says that Q heat transfer expression is QA delta TLM, which is log mean temperature difference, that is defined as delta TLM is defined as delta T2 minus delta T1 by log delta T2 by delta T1. Okay, so let's find out what is delta T2 and delta T1. It enters as 30, outlet is 30, so 30, 30. Water enters at 14 and temperature rises, reaches 22. So this is 14, it reaches 22. So delta T1 is the temperature difference at the start, and delta T2 is at the outlet. So delta T2 is 30 minus 14, which is 16, and delta T1 is at the inlet 30 minus 22, which is 8. So let's substitute that and get delta T, log mean temperature difference. So this value comes out to be 16 minus 8 by ln 16 by 8, so it's 8 by ln 2, and this value comes out to be 11.5 degrees Celsius. So if we just calculate, and so I need to just substitute in this formula, rest of everything is given. So U is 2100, U area is 45 into 11.5, so this is QA delta TLM. So this, if I calculate, this comes out to 1087, close to 1087 kilowatt. So the answer is 1087 kilowatt, UA delta TLM. So the answer for 52 is B. Okay, now 53 is how much the mass flow rate of the cooling water is needed. Okay, so this amount of heat is taken from the steam to the cooling water, so that increases so this is the cooling water, which comes at 14, goes at 22, and whatever Q that we have calculated in the first bit, it increases the internal energy. So it's MCP delta T, so that is T2 water out minus T2 of water at inlet. Okay, so mass flow rate is asked, specific is given as 4.18 kilojoules, and this is 1087 kilowatt. Okay, and temperature difference is 22 minus 14. So this is fairly a simple problem if you just calculate mass flow rate. So this is comes out to be 32.5 kg per second. So 32.5 kg per second, answer is A for this. So it's B and A, and direct a fairly simple problem.